'twas the night before Christmas, when all through the house not a creature was stirring, not even a mouse. We have our narrator, and where should we send her but to a little old place called the Glasgow Science Centre. Santa has promised tonight will be full of fun. There's mischief and games and puzzles with prizes to be won. You can join in with our crafts and make them along with us, and most importantly of all, help us celebrate Christmas. Well, hello, and welcome to the Christmas Extravaganza. Tonight we'll be embarking on 7 festive adventures. That's right, 7. We're going to be helping Santa find his way at night using the stars. We're going to be talking about some stocking fillers and even challenge you to some puzzles. But there's also prizes to be won. I need you to do something for me. Well, something for our friend, Rudolph. You can tell it's Rudolph by his red nose. Say hi. I want you to see if you can try and find his reindeer friends. Make sure to take a note of how many you see and let us know. And if you guess right, you could win a prize. Do you hear something? What's happening outside? Is it snowing? You know, I've got something in my book here about snow. Let's see. Where is it? When frozen white sprinkles start to fall from the sky, that cold white dust makes me question why. Is there some Christmas reason why it snows as clouds shake? Let us find us out together as we make our very own snowflake.
Ho, ho, ho. Hello, I'm Claire and I love winter time. I love the cold, crisp air and the cups of hot chocolate and best of all, the woolly jumpers. I love to make these paper snowflakes in the winter time to decorate the house with. They're super easy and they're so much fun to make. So I thought I would show you how to make them. But first, I've always wondered why snowflakes are these shapes and how they're actually made. So let's investigate this together. If you've ever caught a snowflake on your glove and had a really close look at it, you might have noticed that it's symmetrical and it's got 6 sides. It's a hexagon. You might think that a snowflake is just frozen water, but actually it's a bit more complicated than that. Our snowflake looks a bit different to an ice cube. Wouldn't you agree? That's because an ice cube is frozen water, but our snowflakes are frozen water vapour. Water exists on our planet in 3 main states of matter: solid, liquid and gas. Now, we call solid water ice, and we call liquid water, well, just water, and the gas form is called water vapour. Now, we can actually see these different states when we freeze and cool water. If we were to heat up a pot of water, it would start to bubble and boil and it would make water vapour. But eventually it would cool down and turn back into liquid water. We can actually see this happening on our windows in winter. When it's really cold outside, we get condensation. And we can even see it on our breath when we breathe when we're outside and it's really chilly. If we were to put some liquid water in the freezer, it would cool down and become solid water, which is ice. Our snowflake begins its life as a tiny speck of dust or pollen that catches on to water vapour in the air. Now, when it's really, really cold, that water vapour freezes and becomes an ice crystal. This is the beginning of our snowflake. But why are they a hexagon shape? Well, water molecules in the liquid and the gas state are buzzing around, bumping into each other. But when it starts to get cold enough, the water molecules slow down. And when it starts to freeze, they actually align themselves in the most efficient way possible, which just so happens to be a hexagon. Each snowflake has a unique design because of the unique path it takes when it falls to the ground. Now, snowflakes are blown about by the wind and they bump into different water molecules. Changes in temperature and humidity can also change the design of our snowflake. And our snowflakes can go from flat hexagons called plates that look like this, or they can become long, thin hexagons called needles or columns. Let's make our very own snowflakes now. And to do this, all we need is some scissors and some paper. So if you've got a rectangular piece of paper like this A4, the first thing we need to do is cut it into a square. So to do that, we're going to take a corner and line it up with the edge. Then we're going to cut off the excess. Now that we've got our nice square piece of paper, the first thing we need to do is fold it in half diagonally to make a triangle. Next, we need to fold our triangle in half to make a smaller one. Next, we need to fold our triangle in thirds. So we'll start with our left-hand corner and bring it across. Then we'll fold over our right corner. It's important that these two edges line up nicely, so don't press too hard until you've got them just where you want them. Next, we need to cut off these pointed tips. And now it's time to get creative. So we're going to cut out some shapes from our triangle, and that is going to give us our snowflakes design. And it's much easier if you cut straight lines instead of curvy ones. Now it's time to unfold our snowflake and have a look at its unique design. You can use your snowflakes to decorate a window or even a Christmas tree. Please send in some pictures of your amazing designs. We would love to see what you've created.
You know, once I tried to walk all the way from Glasgow to Edinburgh. It's a pretty far trip. I got about a mile in and I got really sleepy and tired and turned back home. Glasgow to Edinburgh is pretty far, but Santa has to go even further. He has to go all the way around the world. He's only got one night to do it in. And he can't turn back home if he gets too sleepy. I wonder how he does it. Maybe there's something in our book that can tell us how. Here's something. How long would it take me to travel the globe? Is one day enough time to even see all of Glasgow? There's a long way to travel before it gets light. So how does Santa go around the world in just one night?
Hi, I'm Caitlin from Glasgow Science Centre. I don't know about you, but I love Christmas. Have you ever wondered how he does it? how Santa delivers all those presents in just one night? Well, we can answer that with science. So to start off, we'll need an equation. We're going to be using speed is equal to distance over time. We'll start off with distance. According to my research, 108 million people around the world will celebrate Christmas this year. They live on average 1.2 kilometres apart. So if we crunch those numbers together, we can work out that Santa has to travel 129.6 million kilometres. Huge distance. He's only got one night to do it. Well, all of Christmas Eve. So you might think that that works out at 24 hours, but in fact, because of the rotation of the Earth and Santa travelling through different time zones, he actually has 31 hours to complete his task. And that's obviously 111,600 seconds. So now we have our distance and our time, we can work out the speed. So Santa travels at a whopping 1,161 kilometers per second. Incredibly fast. How is he managing to do that? He's definitely not running. And I think the reindeer can only go 25 kilometers per hour. So he must be doing something extra. Santa actually let us in on a little secret. This year, he's upgraded the sleigh with rocket boosters. Let's take a little look at how those work. Before we can talk about rocket boosters, we've got to start with the basics. We need to understand fire. For a fire to survive, we need three things. We need oxygen, fuel, and we need heat. Together, they're the fire triangle. If any one of the elements of the fire triangle are taken away, the fire can no longer survive. Let me show you. In this bowl here, I've got some fuel. By taking off the lid, it's now exposed to all of the oxygen in the air. All we need now is some heat. So you can see we've made a lovely little fire. It's a blue flame, which means it's very, very hot. So this is probably good for roasting chestnuts, but probably not what you thought for launching a rocket. So I can take away the oxygen by putting on the lid, and the fire will go out. Pop that one away. So for a rocket booster, we want a more powerful fire. We can manipulate the fire triangle to take away a little bit of fuel and add a lot more oxygen. That will give us a better fire for a rocket. I have here a replica of the boosters that Santa uses on his sleigh. We've got the same kind of fuel, except this time there's more space for it to mix with the oxygen in the air. By rolling it around like this and making sure it's all coated. So this time we'll have a much more powerful fire. So we know Santa is using rocket boosters to help his sleigh go really fast. But how is he fueling them? Airplanes and things like that might be using petrol, gasoline, fossil fuels. They're really bad for the environment. Santa doesn't want the North Pole to melt, but that's okay. He knows this. He made an environmentally friendly switch. He now uses methane. Methane's a biogas. It's normally made when organic matter is broken down. So it's a bit like what happens inside your body when you eat food. The bacteria in your gut break it down and they create a gas. We wouldn't call that methane. We would probably call that farts. Now Santa's got 9 reindeer as well. They're ruminants. They have a stomach inside them that is really good at making methane. Reindeer farts are actually 10 to 15% methane. So he's got the elves bottling that up to power his sleigh. And I can show you that here. So we know how fast Santa's travelling, and we know how he's fueling his sleigh. But he's not going along the ground, he's going up in the air. So there's another thing we have to consider: lift. Santa's sleigh is perfectly designed. It's aerodynamic, which means it cuts through the air super fast. But it's also an aerofoil. It's flat at the bottom and round at the top, a bit like a wing you would see on an aeroplane. The air rushes really fast over the top and increases the pressure in the air below it, pushing the sleigh up into the sky, generating lift. This is called the Bernoulli effect, and I can demonstrate this for you with some toilet paper. So I am now a toilet roll holder. I'm going to hold it very close to my face, and I'm going to gently blow across the top. Did you see how that generated lift? That was rubbish. We can do better. This will be a lot more extreme. So Santa's travelling through the air super fast and at night time. It sounds pretty dangerous. It's okay though, because he has Rudolph to light up the way. She has a super shiny red nose. Yep, she. Did you know that all of the reindeer in winter that have antlers are girls? That means all of Santa's reindeer are girls. But not all reindeer have shiny noses, unless you look under a thermal imaging camera. So you can see here, this reindeer nose is glowing. And that's because it's warm. When reindeers are out in the snow and they're breathing in air, their noses are nice and warm up that cold air before it goes into their lungs. We can see this through a thermal imaging camera, but we can't see it normally. Rudolph's nose, however, we can see it without a camera. That's because it's bioluminescent. That means it's creating light without creating any heat. I can't bioluminesce for you, but I can show you some luminescence, and I thought we could use it to light up our Christmas tree. So this is chemiluminescence, and we're going to use it to light up our Christmas tree. So there's one important group that we haven't mentioned yet, the elves. They're super important in helping Santa get ready for Christmas Day. Because they have so many jobs to do, they need a lot of energy. And elves, they like to stick to 4 main food groups: candy, candy cane, candy corns, and syrup. Now that sounds like a super high sugar diet to me and you, but elves aren't like humans. They have a really high metabolism. That means their bodies burn through the sugar really quickly. I've managed to pinch one special elven jelly baby. I thought we could test out just how much energy there is in one of these. Apparently it's got 150 times the normal sugar that a human one would have. When scientists want to test out how much energy there is in food, they use a flame test. So let's try it. So the elves eating that high sugar diet, that's going to have an effect on their body. I'm thinking specifically about their teeth. That's all right though, because Santa looks after his elf. They've got elf care. So we managed to get a little sneak preview at the toothpaste recipe the elves used to take care of their teeth. I thought we could try it out here. So the ingredients for this recipe are super simple. We've got some hydrogen peroxide, which is going to be pretty good for cleaning and whitening those teeth. Lovely. And I asked for some fairy magic, so I'm just going to use a couple of squirts of what I've got here. That looks pretty good. And then the last thing is a catalyst. Catalyst helps speed up a chemical reaction, so hopefully it means we'll have our toothpaste pretty quickly. Let's give it a go. Oh, looks like we're getting loads. Oh my goodness, that's far too much. What am I going to do with all this? So folks, that is us at the end of our show. If you have a little look, I think we've got a present. We've all been good enough that I think we can open it just now too. What's inside? Oh, we've got a balloon. And what else is in here? Reindeer. I think I'll keep this safe for later. Now this balloon is floating. So you might think that there's helium in there, but I think because it's Christmas, for extra treat, we have a hydrogen balloon. Hydrogen is a very explosive gas, so I thought to end the show with a bang, we could set it on fire. Merry Christmas!
It's important to look after our planet, but I wonder if there's anything we can do at Christmas to help Earth. This year is our chance to be the world's envy by making this Christmas environmentally friendly. Don't let things go to waste, be recyclably clean. You've heard of White Christmas, but let's make this one green.
Green Christmas? No, the Grinch isn't going to be stealing our Christmas. Oh, you didn't mean that. Okay, we're talking more sustainable? Right, so sustainability is when we protect our environmental quality. We have healthier communities, try using more renewable energy and using less fossil fuels. We as individuals can make small changes in our everyday lives to help the planet in a positive way. We can make small changes at Christmas and we can reduce, reuse and recycle. So we love to give gifts this time of year, and if you're trying to become a little bit more sustainable, you could shop local, buy something that's made of a sustainable material like bamboo, or you could give a gift to somebody that would help them to be more sustainable, like a bottle, a water bottle. And that actually cuts down on single-use plastic, and of course we all know that's really dangerous for our oceans and marine life. So making your presents is a wonderful way to go green at Christmas time. You could repurpose something that you already have in your house, and of course that would keep things out of landfill. Waste is sadly a byproduct of Christmas. We've been talking to our friends over at Zero Waste Scotland, and they have told us some pretty interesting facts. Do you know that here in Scotland alone, we purchase 19,000 miles of Christmas wrapping paper every year? Now that's a lot. It's enough to wrap the coast of mainland Scotland 2.5 times. We also throw away a lot of food, especially in December, Christmas food and drink. As a country, we throw away 50,000 tonnes of food and drink in December alone. If we were to cut that down by 10%, we could save a carbon output of the equivalent of taking 2,600 cars off the road every year. So I mentioned earlier about making the gift for our green Christmas. So we're going to make a Christmas wreath. We've gathered everything from outside, but obviously we need to gather some things that we will have already in our home. So for the base, to create the frame for my Christmas wreath, I'm going to use an old wire coat hanger. And you just pull it out of its shape to make a lovely circle like this. If you don't have a coat hanger, you can use cardboard and cut it into a couple of rings, and I secured it and made it nice and strong with some tape. It's quite handy to have some good wire. You'll need scissors to cut that obviously, and some string if you don't have any wire. So what forms the base of the wreath is obviously lots of little bundles. So that's what we have over here. And I've made about 12 or 13 for something this size. So to do that, we need to gather some of our green foliage. I think I'll get some berries in for this one and some lovely holly. So be very careful with your fingers, obviously. Maybe your adult can help collect that. And what we'll do is take our wire and we're collecting it, all gathering it at the bottom here, and wrap your wire around nice and tight at the bottom like that. That secures everything together. Snip it with the scissors. Nice and tight, no loose ends. and that is one of your bundles. Okay, and that's how we do it. So I have pre-cut myself a few of the wire lengths, about 15 to 20 centimetres each one, and I'm just going to start by placing it over my wire frame. Just sit it like this, and I need to secure it nice and tight. So start off by wrapping it round all the way round. That's like this. It does take quite a long time to make the wreath, but nice Christmas movie on and you can make it, it's good fun. There we go, so that is our first one on. Once that first bundle is attached, we'll then take our second bundle with our second length of wire, and this time where my bundle sort of pointed inside the circle, now we're pointing it out and it slightly changes the direction, and we'll hide that first bit of wire, and then we'll attach it exactly the same way, twisting that wire nice and tightly all the way round. And it's fine if you're using the cardboard. Sometimes you need to use a little bit more wire if you're using the cardboard, because it will be wider than the actual wire frame. Okay, so that's nice, that's the start. Now if there's movement on it here, it's easy enough to take a second piece of wire and find a branch within your bundle and just make sure you secure it. So I'm using 2 bits of wire here, and that's not a problem. And then that's going to be it nice and secure to your wire. Now we're going to do another one. In fact, it's going to take quite a long time, so here are some fun facts about the Christmas wreath. The wreath is often seen as a circular plant or floral arrangement. The circular shape is said to symbolise eternal life, as is the evergreen leaves used to create it. It became a Christmas wreath in the 16th century in Germany and hung on doors to show the period of Advent leading up to Christmas. The wreath has become a holiday tradition all over the world and enjoyed in different variations by many religions and cultures as just a decoration. The word wreath comes from an Old English word writhen, meaning to twist. Phew! That's the fastest time I've ever made a Christmas wreath in ever. Okay, so now we are pretty much finished. I'm very happy. Christmas face. But there's a few things, and if you find there's a few gaps, then of course we want to decorate it just a little bit further. So I mentioned before we had some dried oranges, so they are really nice and they keep it fragrant. And also you might just find some very beautiful and unusual things when you're on your park or garden find to pick things up. So if I see a space, I'm going to attach this. And again, I've just popped some wires through it. Now, the good thing about using a coat hanger is there's already the hook at the top. All right, so that makes it very useful. But again, if you are just using the cardboard, you can simply add some ribbon or some string when you're hanging it up. So a nice little bit of orange. In fact, I think 2 bits of orange at the top there. It's going to be very nice. I quite like symmetry, but it's up to you. You can be as creative at this stage as you would like. So I'm very happy with my Christmas wreath. I might put a bow on it. There are other things that you can do. You might have your favourite Christmas decoration that you could actually add and hang in the middle. That might be quite nice. But again, if anything's looking loose, don't panic about it. Simply add another little bit of wire. So here it is, our very own Christmas wreath, sourced from things that you had lying around your house and from the great outdoors. Now, if you make one, you can either gift it to somebody and you won't even need to wrap it up, or you can hang it in your own home or in your front door. Now, to make sure that your wreath survives the whole of the festive season, it's a good idea to spray it with a mist of water every 2 or 3 days. And that should allow the foliage to take a little drink, and it'll also encourage it to stay nice and fragrant in your house. Before you go, here are 4 quick tips so you can achieve a greener Christmas. Buy a locally grown Christmas tree. They have less carbon emissions, and after you've used it after Christmas, you can either plant it, compost it, or recycle it at the recycling centre. Try and shop local, or give a gift that encourages hobbies or something to look forward to, like a membership or a subscription. Second-hand gifts or pre-loved things can help you clear stuff out of your home and also keeps them out of landfill. Opt out of Christmas cards this year. Do you know in Scotland we purchase 95 million Christmas cards every year? Try sending an e-card instead.
Do you remember how Santa gets all the way around the world in just one night? I'm trying to figure out how he does it. I get lost all the time. How does he find his way around using the night sky? Let's see. When delivering presents at night, it can be a lot of consternations. So if you get lost, remember to use the constellations. Who else could do it? There is no other contender. That means it's time for Santa's Starry Adventure.
Hello everyone, my name is Natalie. I'm an astronomer and I'm so excited for Christmas this year that I just couldn't wait. So I have snuck into our planetarium at Glasgow Science Centre to have a little look at what the nighttime sky looks like on Christmas Eve. Let's have a little look together. This is 11 o'clock at night on Christmas Eve, so we should probably be in bed. But just this once, let's stay up and have a look at the stars, because there are so many. I probably couldn't even count them all. But not everything up there is actually a star. There are other things up in the nighttime sky as well. Things like the moon, planets, satellites, if you're even lucky, a shooting star. But those aren't really stars. They're rocks in space called asteroids that burn up in our atmosphere, and we get that lovely flash of light that we call a shooting star or a meteor. So not everything up there is a star, so how do we spot which ones are stars and which ones aren't? Luckily, stars do something to tell us they're stars. Something all of us know a song about from nursery. Twinkle, Twinkle, Little Star is actually a science song. Stars really do twinkle. They twinkle because of how far away they are. By the time their light gets to Earth, it's really, really spread out, and it hits our atmosphere. And our atmosphere sends the light from the stars in lots of different directions, so that by the time it gets to our eyes, it's a bit of a mess. It's going in lots of different directions, and it makes it look like the stars are flickering, flashing, twinkling. So if you have a look at a dot of light and you can see it doing that twinkling, you know for sure you've got yourself a star. Oh, 1 second, I'm getting a call. I hope it's not my mum seeing him out of bed. Santa? Shouldn't you be getting ready for Christmas? What's happened?
Oh no, it's a disaster! I was doing a practice run for Christmas. Mrs. Claus prepared the hot chocolate. I got out of my sleigh. I got ready to fly, practicing to fly around the world. I turn around, I reach for the map, and Rudolph's eating the map! And now I'll never be able to get home. Christmas is in jeopardy! I won't be able to get home, the children won't get any presents, and worst of all, I'll be lost forever, and there'll be no Christmas. Natalie, I need your help in the planetarium's help to guide me all the way back to the North Pole so I can make it home safely and get ready for Christmas.
That does sound bad, but I've actually got an idea as to how we can help. You have a hot chocolate, have a mince pie, do some stargazing, and we'll get back to you.
Okay, Natalie, but be quick. Christmas depends on this.
Looks like we need to save Christmas. But I do actually have an idea. People have been able to find their way around without a map for a really long time just by using the stars. In fact, rovers that we've placed on other planets, they can use the stars to find their way around. And I think Santa could as well. There's actually a star that lives right above his house at the North Pole that's really, really useful. It's called the North Star, or Polaris. And if he can find the North Star, then he will know exactly which way north is. Now, to find the North Star, I was always told that it's the brightest star in the nighttime sky. But it turns out that that is just not true. It is a science myth. The brightest star is actually this one. It's called Sirius. And if we tried to follow Sirius, we would get very lost indeed, because we are looking south right now. To find the North Star, we don't find the brightest star, or even the second brightest, or the third. We actually have to find a pattern of 7 stars, which are visible all year round from Scotland and even in Glasgow because they're really bright. 7 stars that we call the Plough, or the Big Dipper. Once you've found those 7 stars, you need to use the 2 at the end. We call these the pointer stars because if you use them to point straight across the sky, you come to the North Star. Luckily, it's bright enough to spot in a city, so you should be able to see it any night of the year from Glasgow. So that is how we find the North Star and how we always know where north is. Because if Santa can find that, he can use it to find north, but he can also know which other directions he's going. Because if you're going towards it, you're going the north. If you're going away from it, you're going south. If it's to your right, you're travelling west. If it's to your left, you're travelling east. I'll let Santa know. I hope he's having a really good time at stargazing right now. He must get really, really bored on all those long journeys with no entertainment. But he has got the stars, and when I'm bored, I like to use the stars as a giant dot to dot in the sky to make lots of pictures. People have done that for a really long time. They've made pictures called constellations. I wonder what constellations we can see. Oh no, a great big bear has eaten up our plough, our Big Dipper. This is the Great Bear, Ursa Major, and she looks quite angry because she has lost her baby bear, Ursa Minor. Can you see a baby bear? Luckily, we can help Ursa Major find Ursa Minor, because if you use the plough to find the North Star is right at the tip of the tail of a baby bear. It's a really long tail, and it doesn't look much like a bear, but it definitely is one, because the big bear has a Big Dipper, and the little bear has a Little Dipper. That's how you know you've definitely found our bears. My favourite constellation, though, is one called Orion. Let's see if we can find Orion. He has a red star in his shoulder, a belt of 3 stars. Can you see him? He's just there. He is our hunter. He's really useful as well, because if you follow his 3 stars downwards, he points towards Sirius, the brightest star in the nighttime sky. He's absolutely my favourite though, because I think he looks a little bit like a Christmas bow on its side. Can you see that? Oh, a message from Santa. What's he saying? Help, lost again. Come quickly, we're somewhere with kangaroos. Kangaroos? Santa must be in Australia. How did he get there? Let's get to Australia quickly and give him a call. Santa, what happened?
Natalie, I looked at the North Star and I used it to head south, and I just kept heading south and south until it was gone, and now it's disappeared. It's no longer in the sky. I think we're just going in circles now. Please, can you help?
Don't worry, Santa. We can help you out.
Thank you, thank you, thank you. But please, make it quick. The reindeer are getting tired. I'm about to fall out of the sky!
So Santa's gone so far south that he can't find the North Star anymore. Down in Australia, we won't be able to see the North Star. It would be really, really useful if we could find a South Star. But there actually isn't a bright star where South is, so it's a bit trickier to find South. But I do know a way that we can do it. To find South, you have to find the smallest constellation in the nighttime sky. It's called the Southern Cross, and it is right in the middle of this dusty band, which is our Milky Way, our galaxy, a cross of 4 stars. This is a really useful constellation, so useful that it's on lots of the flags of countries in the Southern Hemisphere, including Australia. So once we've found the Southern Cross, we need to find 2 more stars to find South. They're called Alpha and Beta Centauri, and they're in the hooves of the centaur. I'm not sure it looks much like a centaur. We might have to use our imagination for that one. To find South, we have to use the long side of the Southern Cross to point a line across the sky. Then we have to use Alpha and Beta Centauri and draw a line in between those, perpendicular, going through them in the same direction as the line we just drew. Where these 2 lines meet, that is South. Astronomers call this the pie in the sky method because it looks a little bit like you've just drawn a piece of pie in the sky. I think it looks a bit like a piece of pizza, personally. So that is how we can find South, using the Southern Cross and Alpha and Beta Centauri. I'll let Santa know. I wonder if the constellations in the Southern Hemisphere are very different from the ones in the Northern Hemisphere. Let's have a look. These look nothing like the ones I remember in the Northern Hemisphere. I can see a boat, I can see a clock, I can see a fly, and if we turn around, I can even see an oven. But I do see one familiar face. That's Orion. We've spotted him again. He's got his belt, he's got his red shoulder, but something looks different. Has he had a haircut? He's upside down. The constellations we see in the Southern Hemisphere can look upside down to when we see them in the Northern Hemisphere, and that is just because we're on the opposite side of the Earth. It is getting pretty late though, so I think it is time to head back to Glasgow. But we have been able to help Santa find his way around. By using the plough, he can find the North Star and always know where North is, and he can find South by using the Southern Cross and Alpha and Beta Centauri. Oh, I am getting tired. Oh, a text from Santa. He says, finished our trial run and back in front of the fire with Mrs. Claus. Now I can use the stars. I never need a map again. It looks like we did it. We saved Christmas. It's probably time for me to sneak back home and wait for Christmas the long way. But we do get a glimpse right now of Christmas morning. Oh, one more text from Santa. He says, thank you so much, Natalie, at the planetarium. You're back on the nice list. Wait, I was on the naughty list.
Oh, you've got me having some treats. I've got some mince pies. I've saved plenty for you too, don't worry. I've got something in my book about more treats. Do you want to listen? Okay, here we go. Can you hear the caramelized creatures as they start to stir? I spy a candied cat with its peppermint purr. Don't be alarmed if you spot a marzipan mouse. Where could they all live but in a gingerbread house?
So today we are going to build our very own gingerbread house. Now this is going to be a little bit tricky and it's going to take some time, but trust me, the end result is definitely worth it. We're going to need the whole family for this one. So we're going to need the adults to take care of the baking and maybe some cutting out, and then the kids can get involved with the construction and the decoration. So the first thing that we are going to need for our gingerbread house is a template. We're going to need some walls and we're going to need a roof. So we have already pre-prepared a template. So your template is going to consist of 6 panels. So you're going to need a front and a back. So you need 2 of these. We're going to need a roof panel, so 2 of these as well. and a side for our house, so we're going to need 2 as well. Now we've pre-prepared this, you can find it down in the description below if you want to print that off and use ours. If you don't and you want to get creative and design your own, go ahead and do that, and we'd love to see what you guys come up with. So to start off with, what you want to do is you want to get one of your adults to preheat your oven to about 200 degrees, which is about 180 fan, and then we will weigh out and get ready with our ingredients. So I've started out and I've pre-weighed the dry ingredients, which is our flour, our bicarbonate of soda, and the ginger, which I've got in my bowl here. And then we've got our wet ingredients over here, which we're going to melt together. So our wet ingredients are our golden syrup, our butter, and our sugar. Now that sounds a little bit strange, but yes, sugar is classed as a wet ingredient when it comes to most baking. So we're going to put that all together in the pot, and you're going to want to melt that quite slowly over a low heat until it becomes thick and gloopy. Now you can see over here that this is what I did in my very own kitchen. So just throw it all in the pot together and very gently, continuing to mix it all the time. Just keep going until you get that lovely consistency. It should be around the consistency of your golden syrup by the end of it. All right, so now this has all completely melted and we've got that thick kind of double cream consistency. We're going to pour our wet ingredients into our dry ingredients. Firstly, we'll give our dry ingredients a little mix around, just so that we get all of that ginger incorporated all the way through our flour. That mix. And then we pour the wet into the dry. Yes. All of it in there. Now be careful because this will still be hot and you're dealing with hot sugar, so just be very careful when you're mixing it together. And then that should start to come together into a dough. Might take a while. Keep mixing around. And make sure you're getting all the way to the bottom of your bowl, getting all of that flour all incorporated. You can make a mess as well, that's the fun bit. Can start to tell, that we're getting it there because it's starting to change colour in the bowl as all of the flour is dissipating. Okay, so we're nearly there. So what I'm going to do is we're going to bring the rest of it together with our hands because it will have cooled down a bit now. So I can use my hands, all nicely washed of course. And we'll bring the rest of that together until we get our dough. Okay. I pull a little bit out of the bowl for you guys to see. So it should look like this towards the end. Now you want to bring it together until it's just together. With biscuits, you don't want to mix the flour too much or it'll start to become kind of brittle and really difficult to work with as we go along. So we want a nice soft dough. So once that's brought together, we can start to roll it out and make our shapes. So now we're going to roll out our dough and cut out our panels for our house. So you see here, I've prepped 2 sheets of greaseproof paper. I'm only going to do a little bit at a time just to show you guys. Take maybe about 1/3 of our dough. You might want to do it in batches so it's easier to work with. And kind of flatten it out into a rectangle. Sandwich it between your other piece of greaseproof paper. And then take your rolling pin and roll it out. Now we're trying to get it not too thick, but not too thin. If it's too thin, then our panels will snap when we want to put them together. Too thick, and they'll take much longer to bake, but they will be quite structurally sound. So we're going to try and get a big rectangle. I'm going to keep turning it. Okay, let's have a little check of it. Looks about right. So you want to go maybe 1 centimetre or 2. Should be right. Okay. So now we've got our piece all flattened out like this. We're going to take our piece here and we'll figure out the best way to lay it out so that we can get the most out of the piece of dough that we have here. And then we're going to cut around that. So once we've got our panels cut out, instead of moving the panels, we're going to take away the excess from around the edges. So we've got nice crisp lines and nice crisp edges all the way around. Okay. So I've got one front piece and one side here. And with all the pieces that you've taken off, you put them back in the bowl and you can just scrunch them back together and keep rolling them out to make your next pieces. I'm going to add some windows to my house. I'm going to do that with these little cutters. So I'm going to add a window in the front piece around about here. Push that in. So instead, like you normally would with a cutter, I'm going to leave the piece in there while it's baking. And that just helps to get some crisp lines when we take it out afterwards. And then I'm going to add some windows on the side piece. So little square windows. So. And another thing that you can do with this is you can imprint little patterns into your dough as well. So I'm going to use the top of my round cutter, like that. And my square cutter here to straighten those sides down at the bottom to create a little door shape. Now I've not cut all the way through, it's just a little imprint that will still show up after we've been baking. So now we've got our panels, and like I said, just keep smooshing that together, rolling it out until you have your 6 panels, your 2 sides, your 2 roof panels and your front and your back panel. So what we need to do now is we need to get this onto our baking tray. Now it is still quite delicate, so we don't want to move it too much. So the best way to do that is to take your baking tray and literally hold it level with your bench and just use the greaseproof paper and slide it onto your baking tray like that. Sits it there. You can trim the edges if you want to. If you have a fan oven, then you can do that so that it doesn't flap around in the oven and change the shape of your gingerbread, but otherwise it should be fine. And then this is going to go into the oven for around 10 to 12 minutes, just keep an eye on it, and we are going to prep our sugar for our windows. So our windows are going to have sugar glass inside them, and we're going to do that by using some boiled sweets. These are lemon sherbets that I'm using, so you get that yellow colour in the glass. You can use whichever colour you want, so whichever sweet will make the different colour of glass. So this is the fun bit, where you get to smash the sweets into lots of tiny little bits. So I'm going to use my rolling pin, and I'm going to use the end of the rolling pin this time in a bowl. You can either do this in a bowl or in a little sandwich bag, and that stops the mess flying everywhere. But we're just going to give it a go here. So we're going to smash these up. Ooh. Good. There's a lot of frustration out doing it that way as well. So what we've got is a lot of mess. So what we've got is this little pieces of crystals, what it looks like. And these are going to melt down into our sugar glass. So now we've got our sugar crystals ready to go into our windows. So around 2 minutes before the end of the cooking time, we're going to take the gingerbread out of the oven. So it's not completely done yet. Now, do you remember those shapes that we made, those windows that we cut earlier on, and we left those shapes in there? That was for a reason. So we're going to cut those again. We're going to go around it either with a knife or again with our cutter and take that bit out now. This means that we have nice edges to our windows. So we're going to fill those gaps that we now have with our sugar crystals and then put that back in the oven for the last 2 to 3 minutes of baking. So what that's going to do is going to allow our gingerbread to cook through, but also it's going to start to melt that sugar. And that's going to go all bubbly and lava-like, and it's going to create a lovely sheet of sugar glass in our windows. So once we've got to the end of our cooking time, your gingerbread is lovely and dark colour around the edges, and we've got our nice glass all melted in there. We can take that out and it's ready to let it cool slightly. Now when it's cooled a little bit, you might realise that during the cooking process, your gingerbread shapes have gone a bit wonky, that they're not the shape, nice clean edges that you put in there, and that's okay, that's just what happens. So what we'll do to make sure that we have a shape that we can construct properly is we'll go back to using our template pieces. So we'll use our template, pop it back over the gingerbread piece and just trim the edges down. You can do this with a knife, or if you wait until it's cooled down completely, you can use a grater and file down the edges that way. So once you have a shape that you're happy with, you can leave that to the side, let them cool and set and go completely hard, and then we will be ready to construct. All right, so now we have left our panels to cool completely and they are solid, and we can have a look at those lovely windows, the sugar glass windows that we created. You see, you get this lovely stained glass effect in them, which is really awesome. And we'll be able to see lots of the light shimmering off them as we construct it as well. Now, at home, you guys can use a plate or something to construct on. I'm going to use this cake board here today. And for the glue for our house, we're going to use some royal icing. Now, you don't have to worry about making royal icing, you can buy it in the shops. I've got it here in a piping bag. This is going to give you a little bit more control when you're putting it together, but you can just use a knife and take it out of the pot that way. If you've never used a piping bag before, it's super easy. We're going to twist the top to make sure that stuff doesn't come out, and we're going to use this kind of L shape of our hand. We're going to put that in there, twist it round, and then we can use this hand to apply pressure, and we get the royal icing coming out of the end. So I'm going to start constructing here. This is the part that you're going to want a lot of hands for. You're going to be a lot of people holding the pieces in place while they dry and helping you construct them. I'm here by myself at the moment, so let's see how this goes. So first off, I'm going to start by putting some royal icing onto the board itself, so that I can, spinning. Okay. And I'm going to prep 2 of my pieces at the same time because I don't have anyone to hold it for me. So I'm going to take the inside of the back piece here, and I'm going to put some royal icing, nice dollop of it, all the way along that inside edge, like that. Let's do some more, just make sure it's absolutely going to stick together. Good, and I'm going to take one of my side pieces and do exactly the same. And take along one of the edges. That's the edge that's going to be stuck to our house. Just like that. Okay. So this little line that I've made here, I'm going to push the back piece into that. And our 2 pieces here, we're going to smoosh those together. And it's up to you how you want to do your construction. If you want to make sure you've got some lovely right angles and get your spirit level out, that is totally up to you. I'm going to hold these in place. And hopefully, when I take my hands away, they'll stay together. Ready? Okay, I'm scared. In 3, 2, 1. Yes! Yes! Okay, so now that you've done that, you're basically going to use that principle again to do your other side, so your second side of your house, and the front. Okay, so now we have our house kind of partially constructed. We've got our 2 walls and our front and our back all together and still standing, which is great. I'm going to make sure that it stays that way. I'm going to put some extra royal icing just on the inside corners of these joins, on all 4 corners, and then we will leave it to the side for about an hour or so until our royal icing has set completely to make sure that it's ready for our roof panels. So now that we've left our walls to set and they are pretty sturdy, we can now add our roof panels. And we're just going to do this in exactly the same way as we did the sides. So we're going to go back and use more of our royal icing. And I'm going to put it along all of the points of contact. So all the way along here, along the eaves of the roof as well. Of it again, make sure it's not going to go anywhere. Okay, and we can take our roof panel now. Now you can decide, because our roof panels are going to be slightly wider than the house, so you can decide how much overhang at the front you want. So if we line it up completely flush with the back of the walls, we'll get this little overhang in the front, which is quite nice. Push those together. Just hold it in place for a little bit. Let it go again. Great. So we're just going to do the same thing for the other side. Okay, so now that we've got our roof tiles in place, now they are still going to move a little bit, so they're not completely set yet. What we're going to do is we're going to fill in this little gap at the top with some more royal icing, just to make sure, triple sure, that it's not going to go anywhere. And then again, we've got to leave this to completely harden before we put our decorations on. All right, so I'm just gonna maneuver that. And you can charge someone at home. You can tell them that they've got to hold the roof panels in place for the whole time. I'm just joking. But we should be able to leave that again to the side until it's solid and ready to decorate.
You know, I love this time of year. I can't wait to find out what I'll get in my Christmas stocking. What do you think you'll get in yours? What do you hope to find in your Christmas stocking? For me, I'm expecting some fruit clogging. Stockings always seem a vitamin C kind of business, because nothing says Christmas like a sock full of citrus.
Welcome to the lab at Glasgow Science Centre. My name is Alicia, and we are going to be talking about my favorite part of Christmas, the stockings. Do you hang stockings up for Christmas? Maybe on the fireplace or at the end of your bed? What do you hope Santa will put in it? The tradition of putting stockings up at Christmas time comes from a really old story about St. Nicholas. That's Santa Claus. So the story goes like this. St. Nicholas, as we know, is a very rich and very generous man, and he loves helping people who need it. One day in town, he hears about a poor family, a father and his 3 daughters. Now, even though the family is really poor, the father is too proud to accept any help from anyone. And St. Nicholas wants to help, but this means he has to do it in secret. So, in the middle of the night, he travels to their house, and through an open window, he throws 3 bags of gold, 1 for each daughter. And one of those bags accidentally lands in a stocking that's hanging up to dry on the fireplace. And in the morning, the 3 girls wake up, and they find the bags of gold, and they are overjoyed. So today, we hang up stockings at Christmas time in hopes that Santa Claus will come and fill them with gifts and toys, just like he did for the 3 little girls that night. Come on, let's see what I got. Ooh. What's this? Oh, that's so cute. He's gonna go right there. Oh my gosh. An orange. Do you get an orange in your stocking? Now the orange is actually a symbol of the gold that St. Nicholas left for the 3 girls in the story. I love getting the orange because it is my favorite fruit. Not only does it taste delicious, but it also comes in handy segments so you can share it with your friends and family. But what's more, you can do some really cool science with an orange. Ready? Does an orange float or sink in water? Let's investigate this together. For this experiment, all you need is a large container full of water and 2 oranges. Now, if you don't have a large container like mine, that's okay. You can use a basin, a sink, or you know what, even your bathtub. So first, let's see if an orange floats or sinks. What do you think is gonna happen? All right, ready? Oh, hey, it's floating. So when an object floats in water, we say that it is less dense than the water. Now, density is a word that we use to describe how much space an object takes up in relation to how much matter or stuff is inside of it. If an object is compact and heavy, we say it has more density. And if an object is light and spread out, we say it has less density. So let's try this experiment again, but this time we're going to take the peel off the orange. All right, now the orange is lighter. What do you think is gonna happen? Oh my gosh, it sank. Wait a minute, why does the heavier orange float and the lighter orange sink? Let's take a look. The orange with the peel floats because the peel is porous and filled with all of these tiny air pockets. Now these air pockets make the orange less dense than the water, which causes it to float. When you take the peel off, you do make the orange lighter, but you're removing all of these tiny air pockets. That makes the orange much more dense and it ends up sinking. Let's try another orange experiment. Oh, that's better. All right, so now we know what happens when we put an orange in water. What would happen if we tried to set one on fire? Let's take a look. Anything? No. Okay, so I guess it's not flammable. Orange peels have lots of tiny compartments that are full of oily liquids. Now, when you press on the orange peel, the outside skin stretches and those compartments get squeezed really tightly and it builds up a lot of pressure. Now, eventually, that pressure is going to be so great that those compartments are going to burst open and spray out this really flammable mist. Now, these oils are called hydrocarbons, and they're a bit like petrol, and they are also really flammable. When that flammable mist mixes with the oxygen in the air and hits that flame, we get a really cool fireball. I think we should try it again. Ready? 3, 2,
1.
So why do oranges have a really flammable skin? So oranges are a fruit and they are designed to be delicious, and that means big animals will want to eat them. After the animals eat them, they'll move on to another location and eventually poop out any undigested orange seeds in a perfect glob of fertilizer. And those orange seeds are going to turn into an entirely new orange tree. Now, the orange really wants to be eaten by animals, but it doesn't want to be eaten by fungi or insects. The oils in the skin make the orange waterproof, and that means it's really hard for fungi to grow on it. The oils also act as a really good insect repellent. Now, I don't recommend you do this flammable experiment at home, but I do have one more orange trick that you can try. So we talked about hydrocarbons in the peel of an orange, and one of those chemicals is a very special one called limonene. Now, limonene is what gives an orange its very distinctive smell. But not only is limonene flammable, it has other explosive properties. Limonene dissolves rubber, which is what a balloon is made of. The limonene weakens the surface of the balloon, causing it to burst. Now, another cool thing you can try is putting this limonene all over your fingertip and touching the surface of the balloon, and you can cause it to pop. Ready? Oh, there's something else in my stocking. What is that? Tin foil. Thanks, Santa. Well, I guess I could use it when I'm making my turkey dinner on Christmas. Oh, there's a note. Dear Alicia, I know how much you love science, and I know that you can make a really cool experiment out of this. Merry Christmas, SC. I know just the thing. My gran used to tell me a story about how Santa Claus uses the Northern Lights to find his way home on Christmas Eve. Now, you've probably heard of the Northern Lights, and maybe you've been lucky enough to actually see them. The Northern Lights are colorful lights that appear in the northern sky, right near the North Pole, where Santa's workshop is. They're sort of like nature's fireworks. The Northern Lights are also called the Aurora Borealis, and they're made up of tiny electrons that are blown about by the solar wind, which it's a bit complicated. Just imagine the sun is burping out all of these tiny particles, and when those tiny particles mix with the gases in Earth's atmosphere, they start to glow. The most common colors of the Northern Lights are blue and green. So I can take my Christmas present here, and I can make our very own Northern Lights right here in the lab. Let's do it. Now, in order to make the Northern Lights, I am going to create a chemical displacement reaction. In this conical flask, I have put 200 milliliters of distilled water, and to that, I am going to add 20 milliliters of hydrochloric acid, being very careful not to splash any. To that mixture, I am going to add 6 grams of copper 2 chloride, which is really pretty. Now, we're going to give this a little science swirl to make sure that everything is dissolved. Now, in order to make the chemical reaction, I am going to use my Christmas present from Santa. But I don't think it will fit in my flask like this. Oh, that's better. Now, we call it tin foil, but it's not actually tin. It's made of aluminium. So when I put the foil into the mixture, you want to watch carefully for the bubbles and the mist. That means the chemical reaction has started. The hydrochloric acid is going to start to erode the outside of the aluminium foil. This allows the aluminium to react with the copper 2 chloride. Now, aluminium is much more reactive than copper,
so it will change places with the copper in the copper 2 chloride. This will give us aluminium chloride and copper as a solid metal. We're also going to be creating hydrogen gas, which is very flammable. And it's this gas that we are going to use to create our northern lights. Now, it's best that we do this with the lights dimmed.
Are you ready for a Christmas conundrum? Okay. It's nearly time for Christmas and the opening of presents, but we can't celebrate yet. There's been a change of events. I've been left dreaming of all the custard I will guzzle, but I can't have dessert yet until we all solve this puzzle.
To Caitlin, Rory, Veronica, and Alicia. This year, my gift to you is a puzzle. Can you cut a hole in this Christmas card that is big enough for you to fit through without tearing the card? Merry Christmas, lots of love, Natalie. How do you think that you would get on with this challenge? It's quite a tricky puzzle, but I'll show you how to do it so that you can do it with your friends. Most people are a lot bigger than a Christmas card and would struggle to cut a hole big enough for them to fit through. For this, you'll need a Christmas card and a pair of scissors, and do be careful with the scissors or ask an adult for supervision. Put the card on the table with the folded side closest to you. Cut into the folded side, about 1 centimetre from the left-hand edge, and start cutting straight towards the far side of the paper in a nice straight line. Stop cutting about 1 centimetre before the opposite edge so you don't cut all the way across the paper. Turn the paper around so the fold is away from you this time. Cut around 1 centimetre from the last cut and stop about 1 centimetre before you get to the folded side. Alternate between cutting the folded side and the side opposite. Keep your cuts 1 centimetre apart and always stop cutting 1 centimetre before you get to the far side of the paper. When you're finished, you should have a zigzag of paper. Look along the folded side of the paper. You should have a series of loops of paper. Cut along the fold of each of the loops except the first loop and the last loop. Leave these intact. Carefully pull the paper apart, being careful not to tear it. You should have a large loop. Now try to fit yourself through it. If you look at the cuts in your card, it looks a bit like a maze, but it's actually a loop that is hopefully big enough to go all the way around you. For any given area, there is a minimum size for the edge or perimeter, but no maximum. For example, if I have a piece of paper that's 10 centimetres by 10 centimetres, it has a perimeter of 40 centimetres and an area of 100 square centimetres. But if I had a piece of paper that's 1 centimetre wide and 100 centimetres long, then it would have the same area, but a perimeter of over 2 metres. Knowing this, I should be able to take a card as small as this and fit it around Mr. Bones and I. Have a go yourself, but do make sure that you take out your Christmas money before you cut the card.
That was dastardly difficult, wasn't it? We're coming to the end of our wonderful night. There's still enough time to win our competition. How many of our reindeer friends did you see? Comment down below for a chance of winning. Now, yeah, we're running out of time, and I'm very sleepy, but we do have time for one more poem from my book. You ready? Get comfy. 'Twas the night before Christmas, when all through the house not a creature stirred, not even a mouse. It's come to the time that we must say good night. It's time I curled up, and don't let the bed bugs bite. I've had so much fun. I hope you enjoyed our events. I best get to sleep or I'll miss out on presents. Maybe when you grow up, you'll be a Santa's inventor. Until then, Merry Christmas from Glasgow Science Centre.
Glasgow Science Centre is an educational charity aiming to inspire and engage people from all walks of life. If you enjoyed this evening's presentation, you might want to donate and continue helping us make science accessible for all. If you'd like to donate, we've got the link in our description. Ho ho ho! Merry Christmas to all, and to all a good night.